go together, naturally the leadership will come to Dr. Chandrasekhar and he will have to structure the big dream, if at all they decide. The citation written by the jury of Infosys Prize, they have really nicely worded, and for the benefit of everybody, let me read. Dr. S Chandrasekhar, maybe for a minute? For a minute, has displayed a flair for identifying and synthesizing molecules of biological relevance, topical synthetic interest, and utility to industry. The Infosys committee quickly realized the importance of the work. His research, give big hands. Even bigger hand. Bigger. His research efforts with an impressive degree of innovations and enterprise have led to the synthesis of complex and scarcely available natural products and new molecular entities for affordable healthcare. In addition, his research has provided cost-effective technologies to the chemical industry through identification of new reagents, solvents for specific transformations. Among the 30 complex natural products synthesized in his group, bedaquiline is the first drug approved by FDA after a gap of over 40 years for the treatment of multi-drug resistant TB through simpler transformations and higher yields to ensure affordable access. He, along with a team, has developed a scalable synthetic route for bisoprostol. This is used to prevent gastric ulcer, induce labor, or abortion. It is particularly for self-termination of unwanted pregnancies. This has already been commercialized. His research has drawn the attention of pharma and chemical companies in India and helped many of them enhance their competitiveness. Very good, Dr. Chandrasekhar. Please make your presentation.
Thank you, sir. Thank you, Chairman, sir, for reading the jury's citation for me. And thanks to Dr. Lakshmikanta for arranging this presentation to the open audience. My students actually have been asking for several years that I should give a lecture to them. And I've never done that. And this is my first lecture in the ISCT auditorium as an ISCT scientist. So thank you, madam. My theme of the research since I joined ISCT has been see if we could provide health for all. And these are the people who have been a great source of inspiration, not for science, of course, but for the health they keep up. So if you look at these legendary researchers, they started their careers 50, 60 years ago. And the enthusiasm they show today is as much as they were showing at the age of 20. I think this is what is required to all of us. And again, this slide I show to most of my colleagues, that his holistic approach for the healthcare is through vaccines or preventive medicines. You could have immunomodulators, I mean, all the modern medicines what we have, which are shown here. But India is fortunate that we have additional sources of healthcare, which is of course traditional medicines and yoga. And also we have Swamis and Babas to give us the best health by just praying them. So we have an additional leverage of being more healthy than the rest of the world. And major causes of the mortality worldwide is just listed here. And I'm sure all of us, most of us, would succumb to life using one of these diseases. And cardiovascular still leads to be hitting the whole program. Infectious and parasitic diseases are taking a good shape now, killing us. And cancer, of course, is still a disease which we have not conquered yet. And AIDS and other viral disorders. And neuropsychiatric disorders are running at a much faster pace to see that they overtake all other diseases. So we are trying to address at least few of them, whether we could make some new chemicals or some new processes that we could provide affordable healthcare to at least few of the people in this world. So I have divided my presentation into several short stories, and I would try to have more of colorful pictures than science behind, keeping in view that lots of my non-scientific colleagues are sitting in the audience, and my scientific colleagues will certainly read my biodata or publication. So I've tried to make my presentation more pictorial than chemical schemes. So this first slide quickly shows you the kind of natural products my group has been making for the last 2 decades, which has brought recognition to ISCT in general and also to my group in particular. So they are ranging from very small molecules like paclitaxel to some of the piperidine, very complex natural products. And then this slide again shows you some more natural products which are synthesized in the recent past, as complex as the spiracetylacin, the student is in the audience today, Rambabu, and arenamide, azumamide again, which has really given us a lot of recognition in the HTAC area, which I will share with you a little later. And this slide shows you the kind of non-infringing or freedom to operate processes we have provided to the pharma industry, who have later translated our work into real products into the patient. So if you look at misoprostol, for which our institute got the technology award this year, it was an effort of about 6 years by several students of my lab, Dr. Yadav students, and of course Dr. Mahapatra is also in the audience. And making a Ramarao happy for giving a technology was not an easy job. And the amount of pressure all of us have taking his scoldings every Saturday in our laboratories still is memorable to me. But end of the day, we made the story successful. And one of the major challenges we encountered in this molecule, it has 4 asymmetric carbons. And it's very easy to make the chiral molecule without any difficulty. But the FDA approved US Pharmacopoeia says it should be diastolic mixture, 97 is to 2.1 is to 1 is to 1. And then we don't know which isomer is which, because all isomers have same molecule. So making the diastolic product was the most challenging job, and then we have done very successfully. And quantum paradox, we started with a lot of hope. We failed in the end. But then Bharat Biotech took on from the lead what we gave, and they went on to make the product later. And Bear approach is a stable prostaglandin analog. Again, we made a synthetic approach, which is practically usable, but we also published this work in one of the very good organic chemistry journals. And our group also has contributed in making oseltamivir by non-ischemic acid path, because this molecule is required for treating Tamiflu, and whenever there is an outburst of flu, China starts increasing the price of ischemic acid. China is the largest source of the starting material, and then we have made a process which doesn't use ischemic acid so that we don't require to depend on China too much. And Bedakwali, my friend BG is in the audience, we made a process know-how. Now we are able to make this molecule in gram quantities using very cheap available chemicals, and chemicals are available in India. You don't require to import those chemicals from China. And the latest report says that now, if someone gets tuberculosis and needs a treatment with this drug, they need to shell down $6,000 per treatment. So our process, hopefully if some industry takes up, would reduce the price drastically. And our efforts towards CNS disorders, as I told you, this is one of the major disorders which is taking a toll on the human lives. And these are the major CNS disorders actually. What happens when things go wrong in the brain? Actually, Alzheimer's is one of the top disorders. We get memory loss and we forget what we are doing. And the major problem with Alzheimer's is we will remember what has happened in our childhood, but we'll forget what we have learned yesterday. That means we lose the memory of the latest. So if you learned the driving recently, you will forget driving. You don't forget the alphabet, but you forget the driving. And you forget between the accelerator and the brake. And that's what causes the death to people. And if you buy a new house, then you forget where's your new house. You remember the old house. So this is something very funny disorder which comes with the age. Then we have schizophrenia and depressions. And most of us will undergo depression many times. And Parkinson's disease, and stroke, epilepsy, head injuries, neural disorders, spinal cord injuries. I mean, there are many more disorders in the brain which happen. And my group has contributed reasonably well. Galantamine is the only known drug available today for treating this, and we made the synthetic galantamine in the lab, and also made analogs around this molecule, and which is better than the natural product. So we are looking here for some collaborators that we could take this work forward. And depression, as I told you, is just a common disorder now. All of us, if we don't come first in class, we get depression, or if our girlfriend doesn't like us, we go into depression, and if our boss scolds us, we go into depression. I mean, there are many reasons why we could go into depression. It's a very common psychiatric disorder. 15% of our lifetime we pass through this phase. And unfortunately, women are at a higher risk than men, so the men audience are not happy. And it's more common in the young adults. So I'm out of that, I'm now in the 50 league, so I'm out of this problem. And it doesn't recognize the caste or the rich or the poor. And generally to be treated to a certain extent by using some of the treatments like psychotherapy or some electroconvulsions. And certainly again, it's the first in class a tricyclic molecule which was launched 2 years ago. And we made again the first chiral approach for this molecule, and based on this couple of industries made this drug. And this cartoon shows you that Vincent van Gogh, one of the greatest painters, has drawn a painting of a person when he's in depression, how he looks like. And looking at this picture, the person who painted got depression and committed suicide. So this is such a lively picture he made out of that. And schizophrenia is yet another disorder, which is almost like a bipolar disorder, which is a version of bipolar. And why someone is happy now and within a few minutes he gets very unhappy. And these problems are more so at home for some people. So this is a drug available today, SNP, which is just going off patent very soon. And John Nash, a mathematician and a joint winner of the Nobel Prize in Economics, he has schizophrenia. So again, as I told you, these disorders don't care if you get Nobel Prize or Infosys Prize. I mean, they come to you. And his life was the subject of 2001 Academy Award winning film, A Beautiful Mind. So we have made again this in the lab. The student who made this is in the audience today. And this all of us know, when these disorders become themes of several movies. And the Telugu audience will know that this movie has made name and money for both the father and the son. And we made contributions using one chemical reaction called Claisen rearrangement. So we made use of this reaction, made chemical called cyanic acid, which could create schizophrenia symptoms or Alzheimer's symptoms in an animal model. Because all my the scientists who work in the pharmacology will like to create a disease in the model and then give a chemical to treat it. So they wanted some chemicals that also can cause the disease. Using the same Claisen reaction, we made cyanic acid, published in 2013 in JOC. This chemical could induce a neurodegenerative disorder in the mice model, and then we made sertraline, and we also made acinapine, and we also made galantamine using a similar strategy that we could also provide a cure to the diseases what we are causing. And cancer, as I told you, is yet another major disorder, and something which we never know why this disease comes, despite the fact that we have excellent modeling. And breast cancer, unfortunately, again stands on the top of the list. And again, if you look at the list, breast, colorectal, lung, corpus uteri, ovarian, these are some of the top-notch female cancers. And in male, colorectal, lung, prostate, liver are the next one. And this great man who gave us the best gadgets we love to use and showcase them as the gadgets for tomorrow, has died of a pancreatic disorder. And we have made a chemical which is called adenolide, could cure pancreatic cancer, went on to phase 2 clinical trial, and because of side effects it was dropped. But then we didn't stop the story. With the help of Mr. Praveen, who is going to finish thesis next month at Harvard doing a postdoc with Kishi, single-handedly made this molecule using this nitrosynthesis. This is the only slide I'm using nitrosynthesis slide, but also made about 15 analogs. And one of the compounds, we are able to showcase that this compound has lesser side effects than the parent compound. And this has attracted the original company Pfizer they contacted us to ask us whether the route we have developed is commercially viable, that they could scale it up and do animal trials. But then unfortunately the process is not economical, and then we did not take the negotiations forward. Then tuberculosis, CSIR has played a very major role through OSDD programs. And if you look at this cartoon, about 7 million people were killed and 20 million people wounded during the First World War between 1914 and 18, when weapons were not, scientists were not doing good job those days. But as soon as science became better, better bombs were created, and 10 times more deaths happened globally during the Second World War. And then there's every possibility we get a Third World War, and this will go 10 times or 20 times more. But we don't need a Third World War. We have a small bullet-shaped bacteria. It's a 6-feet bullet, but we have a small angstrom bullet, which is called Mycobacterium tuberculosis. And this bullet could kill more than 600 million people, because almost 40% of the global population are infected with mycobacterium. And the day it becomes vibrant, and then the entire world population will come to 1/3. So these are the statistics on tuberculosis. Nearly 1/3 of the world population are infected. As I told you, 1/3 will disappear if this bullet becomes violent. And 9 million cases appear every year, and about 3 million people die. And 2007 there were an estimated 13.1 million chronic active cases globally, while in 2010 there were an estimate of 8.8 million new cases over that. So this is something we need to address very seriously, because again this is a disease of the tropical countries, that is India and Africa, and America is not going to save us from this disease. So these are the only 4 drugs which were discovered as early as 1950s, are the only drugs available today for treating tuberculosis. And if these drugs don't cure tuberculosis, the only possibility for us is just to die. But then this is a new molecule discovered by Janssen through a consortium study, and this has got the fast-track approvals into clinics. Even without taking up phase 3 trials, it has gone into the market. So this molecule has 2 asymmetric carbons. Very difficult to put on this because it's very crowded. And putting 2 crowded carbons is the most challenging job. Even the original inventor had to make diacetyl mixture of all 4 isomers, and using chiral HPLC they separated, and that is why the cost of this product is very, very expensive. So with the help of Mahapatra and Shyam Kiran, we were able to make this molecule using sharpless chemistry, which is affordable, and we were able to install all the carbons very efficiently and became cover page of EJOC 2 years ago. So then, while working on socially relevant problems, we also went on to see whether all the new chemicals what we make at IRCT could be screened for various therapeutic activities. That's where our National Mold Bank is with us, thanks to DST, DBT, Dr. Yadav, and Dr. Lakshmikantam. So this is an approach we would like to take up very seriously, and the citation of my Infosys Award says that an academic scientist trying to make research for bench to bed. So we thought maybe we should really make that statement very serious. So we have a bench and we have a bed, and then we see that whether we could translate our work from the lab to animals to clinical trials into human disease. And we picked up nitrogen as an evergreen atom, as these people are also evergreen actors for us. So nitrogen is an atom you incorporate into your any molecule, and we start seeing good properties. So we thought that we do an hazard trick for the existing molecules, which is again a very proven molecule, an epothelone, which is a natural product. By just replacing nitrogen at this point, this oxygen replaces nitrogen, and then it becomes drug of choice for treating cancer. So taking a lead from this hazard trick, we worked with Biocon to make a process know-how for converting epothelone to azabothelone, because they had a biotechnological process to make epothelone, and then we were able to convert 50 grams of epothelone to 10 grams of azabothelone. Not stopping there, we have lots of flavonoids available from the natural food what we take regularly. So we thought, could we do the same as that trick on the flavonoids and see what kind of molecules we would be able to get. So we have taken some flavonoids and introduced a nitrogen group, and what we have done was, we have submitted to Mold Bank and just we forgot. At some point of time, Utpal Bhadra from CCMB came to us and said, could we screen some compound for it? And we gave some of the azabothelone which are available in the Mold Bank, And to our surprise, he showed that these compounds have shown excellent activity in the Drosophila models, what he and Monica Paul put together. Then taking a cue from there, we made large number of molecules using molecular modeling at GDK and designed some 150 compounds and outsourced them to synthesize those compounds. So we had a mole bank, those compounds went into the Drosophila model, which were again gone back to lab and made about 150 compounds. And now we have 2 nanomolar compounds which are selective for HDAC6 and 8 inhibition, and we are taking the help of Dr. BG to see that the data what we have is sufficient to go to the next level, that at least we could sacrifice some dogs and say that IICT Mole Bank has taken a compound which is just made in an academic program, has gone all the way through at least the beagle dog, and then we have some INDs going around. So this is the data we have. We have an IICT Barite compound which is showing 0.4 micromolar activity at HeLa cells, which is not toxic. But then we also have an HDAC8 selectivity at 88 nanomolar against HDAC6 at 40 nanomolar. Another molecule is 352 nanomolar versus 51 nanomolar. So we believe that samples made in IICT in the chemistry lab, if they are stored properly, has the potential to become a gold mine. And a strong message to my students who are sitting in the back rows here, that rather than washing your compounds into the sink, if you could just go and wash those round bottom flasks into mole bank cubes, hopefully one day we will get a drug for a disease what we are suffering from. So besides these healthcare programs, my research group also worked on some of the green processes, green technology. Again, we were the first to identify that polymethyl hydroxyloxane, which is a rubber industry byproduct, could be activated using some of the catalysts in the chemistry lab and do organic reactions without using hydrogen or LH or sodium borohydride. And this has led to several publications in our group. And yet another work we are very proud of is, again, we were the first to identify polyethylene glycol, which is a biocompatible polymer, which is again used in several medications, could be used as an organic solvent at the molecular weight of 400, 600. And we could do lots of organometallic reactions and organostatic reactions. And again, one of the reactions, which is hydrogenation, was effectively used to make sure that we get a freedom to operate to make a drug for biopharma. And this slide gives you a glimpse of the entire activity, which shows that my group worked on synthesis of very complex natural products. But with the view, see that there is some social relevance attached to the molecules what we synthesize in the lab. So as I told you, this has given the lead to an HDAC, which is going to hopefully going to preclinic at least. And we also work on very complex natural material, eribulin, what today Javed was mentioning, very, very important life-saving drug for cancer patients. And then we also work on deuterium chemistry, which I did not touch upon today, is we are trying to incorporate deuterium into some of the chemicals, which is an natural isotope of hydrogen, which is abundantly available. And India is the largest producer of E2O now. We have shown that if you replace taxol side chain deuterium, the bioavailability of the drug becomes better. And we also made fully deuterated nicotine. And we are trying to make nicotine patches with the Tobacco Corporation, that this nicotine is more eco-friendly in smoking cigarettes so that we can promote smoking. And all this research, of course, is funded well, and thanks to CSIR and thanks to IICT. And a small take-home message to some of my younger colleagues here is that working on socially relevant projects is the most fulfilling and satisfying endeavor. I really enjoy working on some of the molecules which will have some impact on the health of human beings. And of course, protection of the environment should be considered by developing new technologies and processes. That's where we went on to work on PREG as a solvent. And of course, sustained sample management helps in identifying early leads. As I told you again, there is a success story building up, and I hope more and more stories will come up with the help of the colleagues from RCS, Javed and Malgani. Of course, training of PhDs is one of the most satisfying happiness I get in IICT. And one of my students is become faculty at University of Minnesota. Now he is running a phase 3 clinical trial program for a skin cancer. So I really feel proud that I've trained a guy who is in US, but then helping to get a drug for cancer. And he's the faculty at NIPA. That means we're able to train some students who become again teachers and train again next generation students. Raj is in the audience. This guy is a vice president in a company in the US, and this guy is a faculty at Central University in Rajasthan. So we are able to produce good students who are getting into academics. We also have students who are going to industry and helping industry to make wealth for the industry. And one slide before I conclude is that we are all followers of cricket, and Test cricket is the most sustainable cricket, unlike the one-day matches. We have only 5 players who joined the 250 club, and then I just got the 250 paper. Thanks Vinod, he's in the audience today, and my and these are my mentors and collaborators, Dr. Ramarao, and I'm very thankful to him for really training me, and Dr. Paul, who taught me how to tell lies actually. He was the one who used to ask to do every day 10 reactions, 8 stirrers and 10 reactions. So we used to put some acetone and some color and keep stirring to keep him happy. So he was one of the toughest bosses I've had to work with, but really he likes me so much. Dr. Yadav, who has really nurtured me like his son. Then Pitse, again, most healthiest person I've seen in my life. We landed in 2000 in Germany with me, my wife and son. We had 4 bags of 20 kilos each. And in the Göttingen railway station, there was no trolley to pick the bags. He said, Chandra, 2 bags I take and remaining 2 you and your wife carry. And 2 20 kilos bags he hold like this, and from here till the main gate he walked, and then me and my wife are going behind, trolling the bags behind him. And he was at day 65 years actually. And of course, these are my international collaborators, and special thanks to Jagdish, who's in the audience again, who really used me NMR in a few minutes actually. He doesn't even, anytime he sees my signature, he gets NMR priority. Thanks Jagdish. And again, collaboration, prepared work with him. And this is again 94. I had a very small group. When I have seen Raj Reddy here, he was my early student. Then Arsilu Gaur, Jagdish, and Chandu. And then the group expanded, really very large in 2004. Now it's stabilized. We are happy with the group what we have today. And these are some of the activities we do with my group. We love nature, we go into nature. And of course, we take the help of God to get all the recognition, success in the lab. So we go to temples with the group. And this is a group photo on my 50th birthday, I believe. And of course, the money comes from CSIR, DBT, DSP, Ministry of Health Sciences, Heavy Water Board, Department of Energy, and industrial collaborations, very strong industrial connections we have. And of course, my special thanks to the director, who has been, I treat like Akka, I call her Akka in private. And I have a strong trio actually, like Indian cricket team has a spin trio, Venkataraman, Prasanna, Vishen Singh Bedi. I have a wonderful trio who really push me hard. We fight every day, we eat lunch together, and I really thank Sri Raji and Pratham again, they're all in the audience today. And this is my division. Again, I head the group of National Product Chemistry, but everyone plays a very important role in what we do, and I thank all of them by individual names. And of course, whatever I've told has been done by the people, but this is my family, my wife, my son, a wonderful wildlife photographer. So all the slides I've shown so far have been made by the people who are shown, but this guy has made all the next pictures. He's a wonderful wildlife photographer. He captures them while in the jungle. And all my students tell me that I spend more time in the forest with my son than with them, but then they're working so hard, so I don't like them in the lab. And these are some of the wild pictures he has taken. And again, some birds of India. And of course, this is a rare picture one could see the national animal and the national bird in the same frame, which is a rare thing to get. And this photo has won him the BBC Best Photographer Award. And of course, I thank you all for taking this.
One more example of excellent presentation. I personally liked undertaking problems for research which have social relevance. Very, very laudable exercise. He gave example of 250 wickets. I have best wishes to him. Tendulkar got 100 centuries. So let us have 100 papers having 100 citations. I have all my best wishes to him.
Thank you.
Maybe you are already having. Likely. I feel personally happy to be associated with ICT. Today we heard 3 lectures having very, very important awards of our country, most coveted awards of our country. But when I received Padma Bhushan of this year, what I came to my mind, I must tell you, sometimes these awards are incidental. So we should learn smiling whether we get awards or we don't get awards. Keep on doing very good work all the time. That is the... Thank you very much. And let me give...
Dear colleagues and students, on behalf of our director and my own personal behalf, I thank our RC chairman and members for their presence, suggestions and remarks. My sincere thanks to all of you here for accepting our invitation and presence here. Thank you very much.